At the end of this video, you should be able to calculate the formula mass or molar mass of any given compound. Chapter 7, Section 3, Using Chemical Formulas. As you have seen, a chemical formula indicates the elements as well as the relative number of atoms or ions of each element present in a compound. Chemical formulas also allow chemists to calculate a number of characteristic values for a given compound. In this section, you will learn how to use chemical formulas to calculate the formula mass, the molar mass, and the percentage composition by mass of a compound. Formula mass. In Chapter 3, we saw that hydrogen atoms have an average atomic mass of 1.00794 AMU, and that oxygen atoms have an average atomic mass of 15.9994 AMU. Like individual atoms, a molecule, a formula unit, or an ion, there is a characteristic average mass. For example, we know from the chemical formula H2O that a single water molecule is composed of exactly 2 hydrogen atoms and 1 oxygen atom. The mass of a water molecule is found by summing the masses of the 3 atoms in the molecule. In the calculation, the average atomic masses have been rounded to 2 decimal places. The mass of a water molecule can be correctly referred to as a molecular mass. The mass of 1 sodium chloride formula unit, on the other hand, is not a molecular mass because sodium chloride is an ionic compound. The mass of any unit represented by a chemical formula, whether the unit is a molecule, a formula unit, or an ion, is known as the formula mass. The formula mass of any molecule, formula unit, or ion is the sum of the average atomic masses of all the atoms present in its formula. The procedure illustrated by calculating the formula mass of a water molecule can be used to calculate the mass of any unit represented by a chemical formula. Note, in each of the sample problems that are in this section, the atomic masses from the periodic table on pages 130 to 131 of your text, or inside the back cover, have been rounded to 2 decimal places.
Like individual atoms, molecules and ions also have a characteristic average mass. To find this mass, we add the average masses of the atoms making up the compound. In a molecule of water, there are 2 atoms of hydrogen, so we multiply the atomic mass of hydrogen by 2. There is also 1 atom of oxygen, so we multiply the atomic mass of oxygen by 1. We then add these masses to find the average atomic mass of the whole molecule. A mole is a quantity similar to a dozen. There are 12 items in a dozen, and 6.022 times 10 to the 23rd items in a mole. A dozen eggs, a dozen bagels, and a dozen pencils have different weights or masses and have different properties. The term dozen tells you that there are 12 of the item. Similarly, a mole of iron and a mole of copper have different masses and have different properties, but both represent the same number of atoms, 6.022 times 10 to the 23rd atoms.
Molar masses. In Chapter 3, you learn that the molar mass of a substance is equal to the mass in grams of 1 mole, or approximately 6.022 times 10 to the 23rd particles of the substance. For example, the molar mass of pure calcium, Ca, is 40.08 grams per mole because 1 mole of calcium atoms has a mass of 40.08 grams. The molar mass of a compound is calculated by summing the masses of the elements present in 1 mole of the molecules or formula units that make up the compound. For example, 1 mole of water molecules contains exactly 2 moles of hydrogen atoms and 1 mole of oxygen atoms. Rounded to 2 decimal places, a mole of hydrogen atoms has a mass of 1.01 grams, and a mole of oxygen atoms has a mass of 16.00 grams. The molar mass of water is calculated as is shown on page 223 of your text, or on the screen now. You may have noticed that a compound's molar mass is numerically equal to its formula mass. For instance, in sample problem 7-6 on page 222 of your text, the formula mass of KClO3 was found to be 122.55 AMU. Therefore, because molar mass is numerically equal to formula mass, we know that the molar mass of KClO3 is 122.55 grams per mole. At this point, you should be able to calculate the formula mass or molar mass of any given compound.